Now let's go ahead and take a look at part C. Now, if I were you, I would circle this problem, highlight this problem, put a star next to it, because that is going to be the most challenging kind of question you may see. Well, what makes it challenging? What makes it challenging is that, well, for the earlier question, you can either, well, you're given the A1 and D, or you can easily spot out the A1 and D. But now, right here, we're like, wait, hold on. What's going on here? There's no A1 and there's no D given. They're just two numbers. Okay, they're just two numbers. Now, there are a few ways you can handle this situation. You would say, oh, you know what? Well, you have these two numbers. And since we're doing arithmetic sequence, that must be arithmetic, so we're adding some numbers. So from A4 to A13, you're thinking like, yeah, so from A4 to A5 to A6 to A7 all the way to A13, there are 9 times that you have to add a D. So you can say 9D is equal to 68 minus 23. And that gives you 45. So you can say 9D is equal to 45. So D must be 5. You're like, great. And if you know D is 5 and you know A4 is 23, then you can just backtrack. Like, oh, A4 is 23. So what's A3? A3 would be 18. A2 would be 13. Then what's A1? Oh, A1 must be 8. Now, this is something that a middle schooler can do. So can you. Okay. If it's a multiple choice, you can figure this one out. There should not be a challenge. But now, I also want to show you a more systemic way of tackling this. Now, the biggest challenge right here is that we have two unknowns. If we have two unknowns, how many equations do we need to solve two unknowns? Based on what you learned in Algebra 1, if you have two unknowns, how many equations do you need? You will need 2 equations. So where are we getting 2 equations? So you can say, well, we have this, right? Don't we? We have this lovely equation to start. So if we have A4 and A13, then we know the n value. So we can say, oh, 23 is equal to D times 4 minus 1 plus A1. Hey, we have 2 unknowns right there. We have the D and A1 being unknown. And on the other hand, we can write down 68 is equal to D times 13 minus 1 plus A1. Now, what I want to emphasize here is the fact that if you see 2 unknowns and you have 2 equations, then you know one thing for sure. You can solve it. So 23 is equal to 3D plus A1. And then you have 68 equals to 12D plus A1. And for me, I think it's a lot easier to solve for A1. So we say A1 is equal to 23 minus 3D. A1 is equal to 68 minus 12D. And then we set them equal to each other. So we have 23 minus 3D, it's equal to 68 minus 12D. So 9D will equal to 45, which is something that we saw earlier. So D is equal to 5, lovely. And then I'm going to use this equation here, smaller number, a little easier to handle. Put the 5 into the D. Then we say 23 minus 15, it's equal to A1, so A1 is equal to 8. We still got the same 2 numbers, but this is a more systemic way, more organized way to show our work. More convincing. Okay, so to write out the nth term notation, then we say, oh yeah, so now we have the D, which is 5, and then n minus 1, then n plus 8. So 5n minus 5 plus 8, you have 5n plus 3. being the nth term notation, nth term expression. Pretty challenging. Okay, again, the setting of this question is that we did not give you the the A1 and the D, and you could actually figure out the A1 and D. Okay, and I show you this system of equation way. Okay, which makes it a lot more clear what's going on.